Hello everybody, we're getting ready to do section 20 of our SAT Math Level 2 preparation. And for today's classwork, you will have 6 points. So go into your notebook guide. And you got 4 points, so go into your classwork sheet, have that one out. Students, put your name, date, period. Onliners, put your due date here. And we go into our first page here, a notebook entry. A vector in a plane is defined to be an ordered pair of real numbers. A vector in space is defined as an ordered triple of real numbers. On a coordinate system, a vector is usually represented by an arrow whose initial point is the origin and whose terminal point is at the ordered pair or triple that names the vector. Vector quantities always have a magnitude or norm, meaning the length of the arrow, and direction, the angle the arrow makes with the x-axis. So we have a norm and we have direction. Vectors are often used to represent motion or force. Properties of two-dimensional vectors can be extended to three-dimensional vectors. We will express the properties in terms of two-dimensional vectors for convenience. If vector v is designated by v1, v2, and vector u is designated by u1, u2, vector u plus v is designated by u plus v1, u1 plus v1, u2 plus v2, and called the resultant of u and v. Vector v has the same magnitude as this here. Vector v, this means vector v here, but has direction opposite that of vector v. So we're talking about negative vectors here. This is negative vector. Vector negative v has the same magnitude as vector v, but has a direction opposite that of vector v. So it's just opposite. On the plane, every vector v can be expressed in terms of any other two unit magnitude 1 vectors parallel to the x and y axes. If vector I equals 1, 0 and vector j equals 0, 1, then vector v, which equals ai plus bj, where a and b are real numbers, is the same as vector ab, a unit vector parallel to vector v can be determined by dividing vector v by its norm. Remember what norm was? Denoted by, this is our symbol here, symbology for the norm of vector v when you have these two bars on each side, and equal to, and then here's where we calculate a vector is a squared plus b squared, and then we take the square root of that. It is possible to determine algebraically whether two vectors are perpendicular by defining the dot product or the inner product of two vectors. So we have vector v is v1, v2, and vector u is u1, u2. So vector v times vector u would be equal to v1, u1 plus v2, u2. Notice that the dot product of two vectors is a real number, not a vector. Two vectors, say vector v and vector u, are perpendicular if and only if vector v times vector u equals 0. So you should have all this, students, within your pre-calculus background. If you don't, contact me and I can provide you lessons to help you get your vector education going here. Okay, let's try an example here. So A, let vector v equal 2, 3 and vector u equals 6, negative 4. So when we do that, what is the resultant of vector u and vector v? So we're talking about what is the resultant? the resultant of u plus v. So what is the resultant of u and v? Is the resultant of u plus v equals 6 plus 2, negative 4 plus 3 equals 8, and negative 1. So the resultant of these two here, there's a lot of terminology here that you need to know. That just means that you add common elements here of each vector. And 2, what is the norm of u? So we're going to find the norm of here. How do we find the norm of u? So to find the norm of u, we go 36 plus 16, 6 squared plus negative 4 squared, and then that's radical 52, which is 2 times square root of 13. So we're learning a lot of terminology here. If you don't have any vector background, contact me. 3, express vector v in terms of I and j. So this is vector v up here. How do we express that in terms of I and j? So vector v is 2i plus 3j, 2i plus 3j. To verify this, use the definitions of vector I and vector j, and vector j times vector v, which would equal 2 times 2 times 1, 0 plus 3 times 0, 1. And when we do that, we come up with 2, 0 plus 0, 3, which equals 2, 3, which equals our vector v. So that would be expressing vector v in terms of I and j up here. And number 4, are vector u and vector v perpendicular is the question. So to find that, we multiply vector u times vector v, which is 6 times 2 plus negative 4 times 3, 12 minus 12 equals 0. Therefore, vector u and vector v are perpendicular because the dot product is equal to 0. That's why they're perpendicular. And we just proved it down here. Okay, B here. If vector u equals negative 1, 4, and the resultant of vector u and vector v is 4, 5, find vector v. So to do that, let vector v equal v1, v2. The resultant is vector u plus v equals negative 1, 4 plus v1, v2, which is 4, 5. Therefore, negative 1 plus v1 and 4 plus v2 equals 4, 5, which implies that negative 1 plus v1 equals 4 and 4 plus v2 equals 5. Thus, v1 equals 5 and v2 equals 1. So vector v, therefore, equals 5, 1 by this process here. And that is Section 2.0 SAT Math Level 2 Prep. Animated PowerPoint Math Video at AOL.com for questions or materials. Thank you.